So kung masonry wall, half between the middle and edge of the wall. So if you can see here, this is the middle of the wall and half of the middle of the masonry wall. So kung si HB walling ni siya, ang iya ang half of the edge no of the wall, half pagina sa murag 1/4 no from the center of the masonry wall, diha ang atong consideration sa bending. So diha ang uh, bending. So or halfway between the face of column and edge of steel base plate. Kung ay steel base plate ang atong column, no? So, uh, it should be halfway between face of column and the edge of steel base plate. So, kung diri tama ang atong base plate and from the face of column, half from the face of the column, this is our face of the column, half ana. So, that is, if this is A, no, then this will be the distance A over 2 as the direction of our bending consideration. No? So, diha mo bend siya. Kani, no? Kung na-ay steel plate. Kini, nakikita siya sa wall footing siya. So, at the surface of the wall, kung masonry wall siya, si HB, so from the center, dito siya sa katunga-tunga from the center sa ato ang masonry wall and then towards the edge of the wall, so at the center of that. Okay, so these are, can you still see my presentation, class? Please say yes.
Yes, ma'am.
Okay, so are you clarified with the first slides that I have presented? What is the shear factor reduction? What is the shear reduction factor, gani? What is the shear reduction factor, gani? 1, 2, 3. Boleh maka-answer? Answer just the name and answer. Ja, Braga. Okay, very good. What is the steel covering for those section exposed to soil? Concrete exposed to soil. What is steel covering, ganit? Pila ang steel covering? Braga. 1, 2, 3, 4. Wala na.
Labaan, ma'am.
Unsa?
75 mm, ma'am.
Sikinsa ni? Please identify yourself, gani. Dali dayo.
Labaan, ma'am.
Labaon. Okay, 75 and okay, that's 2.1. Sige. Alright, let's continue. So, footing supporting a circular, napod siya no, a regular polygon shape, or columns or pedestal. The code, section 5.15.3, permits to treat the section as square. So, consider na to siya as a regular section into square, no? Or bending. So, design steps for footing with respect to critical section for bending. First, we determine the factored net soil pressure. Second, we solve for the ultimate moment by cutting a section, considering section for bending. And then we solved, if you can still remember this formula, R sub n is equals to mu over phi bw d squared, where for flexure, the reduction factor is 0.90, and for shear, the reduction factor is 0.75. Now we're talking of bending, so we will use for flexural reduction factor, which is 0.90. So again, you recall your reinforced concrete, the steel ratio, mm, rho, which is equals to 0.85 Fc prime over Fy times 1 minus square root of 1 minus 2 times R7 over 0.85 Fc prime. So, tinanan po na. Then, always remember this, katong di ginatulim tanong, ang rho nga gamiton, dapat dili siya mag below sa rho mean, where rho mean is 1.4 over Fy, and or you could use 0.75 square root of C prime over Fy and choose whichever is bigger for the rho minimum, then that should be the rho mean. And of course, our rho map, it should not be greater, the rho that we will be using should not also be greater than the rho max. No? Okay, and to solve for the area of steel bars, it's just equals to rho BD, where rho BD, where the rho that should be computed based on this formula, uh, and it should not be below the rho minimum. So in the sixth step, solve for the number of main reinforcement. No? So to solve for the main reinforcement, solve for the number of main bars, you have to determine the area of the steel bars once divided by the area, no? Where your spacing of the main bar is equals to 1,000 times the area, no, para sa imo ang footing, divided by the area of the steel bars. So this spacing is for wall footing, no, or continuous slabs. And however, for all types of footing, except for wall footing, you can compute this as for the spacing of your main steel bars is equals to PW. Again, the PW is the perpendicular dimension of the width of your footing minus twice of the concrete steel covering minus the diameter of the main reinforcement divided by n, the number of steel bars minus 1. So you can use also this formula for other types of footing. Then check for the maximum spacing based on NCP 2015 section 407.7.2 that the maximum spacing of the pond reinforcement shall be lesser among this formula or among this value 3 times the total depth of our footing, or it should not be greater than 450 mm. Okay, so that is based on our NSP. And then solving the number of spacing of temperature bars, we have here from the NPCP uh, our area of the temperature bars if our tensile strength Fy is equal less than 420 MPa. So you can compute for the temperature bars is equals to 0.0020 times the gross area. No? And then deformed bars or welded wire reinforcement greater than or equal to 420. You can have this formula 0.0018 times 420 over Fy times the area, the gross area of the concrete, gross area of the concrete. And then R is equal to 0.0014 of the gross area of the concrete. So again, for the temperature bar spacing, katura gyapon, no? You have there BW minus twice is the covering minus the temperature bar diameter over n minus 1. And the spacing for shrinkage or temperature enforcement should not exceed, no, or shall not exceed the lesser of 500 times the total depth of a footing, or 450 mm. So dapat dili siya mag-exit, no? Sa 5 times the uh, total depth. Okay, let's go to a simple illustration. So you have there a 3 by 3 by point 4 footing with a point 4 by point 4 column at the center. So 3 meters. Total depth sa tuang footing is point 4. And then ang atong column dimension, point 4 by point 4. And it is located at the center of our footing. So the base of the footing is 1 meter below the ground. So meaning the base of our footing here is 1.2 meters below the ground. If this is the ground surface, then the location of our base of the base of our footing is 1.2. And considering unit weight of the concrete is 24 kilonewton per cubic meter, and unit weight of the soil is 18 kilonewton per cubic meter, that is about the footing, and using effective depth. So given ang effective depth, which is 315 mm for all calculations, then the ultimate load on the deck is equals to 1.2 times dead load plus 1.6 times live load. Then what is required is determine the factored shear force, VU, at critical section for one-way shear. So one-way shear. And then calculate the nominal shear stress in footing in FPA in at critical section for wide beam action. So nominal shear stress, factored shear force, nominal. So VU, V sub N. Calculate the factored shear force at critical section for two-way shear. So katong punching consideration and nominal. So VU gihapon for VU sub P, punching, and here is VN sub P, no, for punching. If the dead load is 364 kilonewton and the live load is 280 kilonewton, and there is a horizontal load, no, applied to the column, which is 94 kilonewton live dead load and 107 live load. So, saan man napag-determine sa ato ang shear force? So, first is to determine the factor shear force in kilonewton for one-way shear. So, namtay PU, nga dead load, live load. So, we use this factored formula or the ultimate load. So, you have for the vertical, PU is equals to 884.8 kilonewton using the load combination 1.2 and 1.06. So you have your uh, 884.8 PU, 284 DHU. This horizontal. So for the MU, you have to compute for the moment, no? Moment induced by this horizontal loading to our column. So if you compute that, that is 1 plus zero point 0.4, no? Because if this is from the section, 1 meter from the section of our load application. So if this horizontal load application is 1 meter to the top of our top surface of our footing, so 1 meter, and if you sum up moment at the bottom, no? So the moment arm should be 1.0 plus zero point 0.4. No? So this horizontal loading force applied to our column would induce a moment, no? A moment of 284 times 1.4, or that is 397.6. So you'll have for the uplift, so for the foundation pressure per unit, so Going back, no, to the eccentricity, uh, you have there mu over p since natay moment, diba? So, ang eccentricity is equals to uh, e moment over the vertical loading. No? So, therefore, there is this eccentricity, which is 0.449 meter. No? So, then our b over 6 is 3 man ang ato ang width divided by 6. So, that's 0.5. So, if we check, no, katong sa uplift bitaw, if you recall that in our previous the foundation uplift, so dapat be over 6 i-check na to, no? uh, 0.5 dapat ang ato ang eccentricity uh, should be below b over 6 since 0.449 man, so 0.45 run around of niya ang b over 6 is 0.5, so it means na walay uplift na hitabo, no? So walay overturning ang ato ang routing. So that is how to check if there is an uplift. Therefore, since there is none, then we can use the formula b over a for the q unit plus and minus 6m over d squared. So given naman ang p, na may area sa atong footing, which is 3 by 3, so that's 3 squared. And for the moment, result is 397.6 kilonewton meter divided by b, then the squared of the effective depth, which is given 315 uh, ano, b squared, where this is the dimension of our footing, no? Squared b times the width of our footing. So therefore, to solve for the q max, so you use this plus sign. For the q min, you use this minus sign. So if you use the plus sign, you'll get 1.186.67 kPa. So this is the maximum. So the intensity of the soil pressure due to these loadings applied to the column and transmitted to our footing. So of course, our soil would react. No? So there is this uh, maximum intensity of the soil pressure experience as 186.67 kPa. And for the Q min, by using this minus sign here, that is 9.96 kPa. Okay, so for the solution, na naman tayo Q min, so ato na i-label sa atong free body diagram. In your solution class, it must be labeled similar to this how it is being solved. No? Ano, labelan yun. Dapat na ay uh, sakto nga labeling. No? So, solving for the what is required, no? Factor shear force, VU for the wide beam shear. So, to solve for this, you get the pressure. Dapat, di ba, ang QU is equals to uh, the net, no? The area. Dapat the net area of the soil pressure. Since nakuha naman na to ang net area, and this section here, so makita na to, makuha na to na to solve using this portion here. No? So, kung ang max 3 is 186.67, and then kani nga portion diri, so again throw na po no ang ato ang shear capacity, no? Factored shear will be equal to the q unit, no? uh, of our soil pressure. So okay, kita naman nato ni given naman ni, so i-equate na to ni siya, but to solve for the Q unit, we have to just determine the area of this, di ba? Kining nga portion, trapezoidal. So to solve for the trapezoidal, unsaan man nato ni? We can use unsa man ratio and proportion or pwede po mag-caltech daw ka, no? Using caltech. But by ratio and proportion, you can simply make similar triangles, no? Pwede mo mag-similar triangle din ha, kana straight din mo na din ha. 96.9.96 kPa. So, kung kabalo na ka din na, pila po diri nga portion, no? So, at the portion, the ratio and proportion. So, you can determine the area. So, bigger triangle is the smaller triangle. So, you can calculate for the uh, this height of the uh, trapezoidal section. Okay. So by ratio and proportion, you can compute and determine that it's 1.28.65 kPa. So if you have that, using the formula of trapezoidal area, so 1/2 times the sum of the two sides, parallel sides. Then multiplied by the distance between this. So pila po ni ang distance diri. No? That is say this is z. So to solve for z, if we know that this is the distance, no, kabalo naman ta kung say dimension sa ato ang uh, footing. No? Yeah, ang shear for one way is the distance man from the face of the column. So, if this is 3 meters, so kung katungaan na, no, kung 0.4 by 0.4 ang ato ang column, so, and you determine this as 0.315 meters, then you can compute for the z, which is equivalent to 0.985 meters. So, pila ka ito nga, 1.5 minus 0.315, no? So, you'll have this 0.985 meters. Okay. So, then, if you can solve, we can now determine the alternate shear capacity for wide beam shear. No? That is the or one-way shear for the first determination natin. Okay? So, yeah. So, this is how to get the value of the ultimate shear strength or shear capacity, no? For one-way shear. Di kaduha, kato na pong nominal. Mao ra gyapon, no? So, through nato ang katong formula. So, nasolve naman nato ang ato ang ultimate shear strength, which is equals to Q unit. No? Dito nato ibase sa ato ang pressures nga sa soil. And again, kung magkuha ta og nominal, it just multiplied by or divided by the our ultimate strength divided by the shear factor, no? 0.75. So, i-divide na to, then following this formula, B sa UW over P over VW times T. So, where we determined our V ultimate shear strength, no? Multiplied by, okay, 1,000, no? Kay ang ato ang gigamit nga dimension is in mm. So, you multiply by 1,000, no? O 65.89 para mahiyo siya Newton. And that you'll have a unit of MPa. So, for the nominal shear stress, it's 0.657 MPa, using this formula. So, di kalimutan na ang formula ang shear stress, nominal shear stress formula. So, third nga requirement is calculate the factored shear force at critical section for two-way shears. Again, kung two-way, pwede duha atong gabiton no kani the ultimate share for punching is equals to Q unit times the area outside, or pwede na ito ultimate shear strength for punching is equals to PU minus Q unit times the inner area. Okay? So, again, di ba, kani, muna siya ang D over 2 sa punching from the face of the column to the perimeter no, for punching is both sides no, D over 2. D over 2 from the face of the column. 3 put D over 2, D over 2. So, that defines the perimeter beside the O. And then, to compute, let us try the first consideration. No? So, kung uh, VU katong outside ng area. Ano yan? So, if we use this formula, then we determined already the VU, yung factored shear force, combined loads. Then the area outside is 3 times 3, so that's 3 squared. So you have the Q unit of 98.311 kPa. And for VU, you have now uh, for the VU actual, then it's just equals to Q unit times the area, outside area minus the inner area. 0.715 squared. No? Kaning inner area mo siya. Itong sa punching na perimeter. 0.715. No? Yan sa pagkang 0.715. So, ang 0.375 divided by 2 plus 0.375 divided by 2 plus zero point 0.4, or that is simply zero point 0.4 plus 0.315. No? Ito ang effective depth. So, manang 0.715. So, that is for the ultimate strength for shear strength or shear capacity for punching of our for two-way. So, nakuha na to. So, for punching and for the nominal shear stress sa katong two-way. So, same ra kayo. Just use the formula, of course, kung sa to ang capacity for punching, again, divided by 0.75 times BO. Karon ang BO is katong perimeter, no, nga 715 mm or 0.715 meter. Pat man to sila ka sides, then multiplied by the effective depth, 315. So, there is 1.24 MPa. So, take note class, you must be consistent of the unit, no? Kung it is MPa, so you multiply this by 1,000 ang kilonewton na shear value, then divide all the dimensions by its mm no? Unit para MPa mo ko. Okay? So, do you have any clarification with regards to the shear? Again, for 5 points, can I hear what is the formula for the shear capacity of our footing? What is the formula for one-way shear? So the formula for one-way shear? 1, 2, 3, 4, 5. Oh, wala yung wala. Ano pa ba? Shear capacity. Ultimate shear capacity. Hello, are you there? And so to'y formula for ultimate shear capacity, shear force
Ben,
equals, yes.
Ventas
Sa to, di, laki una, kinto to nakauna. Kinto to,
Ventas ma'am. Ventas ma'am. And VU equals to phi times
dili
0.17 lambda
maklaro
squared
imo.
of F prime
Kwenta, sige, sige.
C. Ako to ma'am.
Ma, putol-putol mong ka-contest.
Laging
True ha. Ila?
VU is equals to
Unsap.
phi times 0.17 lambda square root of F prime C BWD.
Okay. Sige, that's 2 points. Uh, what is the formula for two-way shear capacity or two-way shear? So the formula.
Labaon, ma'am.
About, go ahead.
BU is equal to QU o kuan din, ma'am, area out times area out, ma'am.
Q, pwede. Sige. Other, napay other formula.
Tizon, ma'am.
Kato-kato na istorya. Kinsa to?
Tizon,
Kinsa
ma'am.
na? No, not Tizon. Tizon to?
Yes, ma'am.
Oh. Sige, Tizon. Go ahead.
So the other formula is VU is equal to PU, which is the factored axial load minus QU net times times A, which is the inner area.
Okay. So, Tizon. Okay. Okay, thank you. Let's go to the next example. For this is now for bending. No? We're done with the punching. No? So we're done with the one-way shear and two-way shear. So let's go to the bending. So this an example here, 2.4 meter by 2.4 meter square footing na siya gisuportaan nga column, 350 mm by 400 mm. So ang footing nag-support siya sa column. Dayon, ang total thickness of footing is 0.6 meter or 600 mm. And it carries factored axial load, PU 1880 kilonewton. So FC prime, using FC prime is 20.7 MPa and FY as 280 MPa. And for the reinforcement, for uh, main reinforcement, 20 mm diameter for both ways. And clear bar covering, steel covering, using 70 mm. And of course, using strength reduction factors for shear, 0.75, 0.9 for bending. Question. Calculate the shear stress in the footing at critical section for wide beam action. No? So, unsa ganito ang critical section, ang distance from the face of the column for wide beam sa action or one-way shear. So, ito yung distance on the face of the column. 1, 2, 3, 4, 5, 5. Wala yan. So that is D, distance, no? Effective depth from the face of the column to the critical section. Or one-way shear. No? Dayon, kinipod, shear stress gihapon at critical section for two-way shear, which is considering the punching, diba? B sub O. And B sub O from the face of the column is just effective depth over 2 around the column. Then, determine the number of pieces of 20 mm reinforcing bars required in each direction of the footing. So, these are the three requirements for this problem statement. So, how to solve this? To solve for uh, So, ito i-drawing, no? Ang formula o ang problem. So, total thickness, 600 mm or 0.6 meters. Then, na siya factored load nga gi-carry ang column na 1,818 kilonewton. So our column dimension is for 350 by 400 mm. Ang footing dimension, 2.4 by 2.4 meters. So saan ang effective depth pag-compute? So one-way shear. So again, total thickness minus steel covering na 70 mm or that's 0.07 minus the half of the diameter of the main bar, which is 20 mm as specified in the problem. So therefore, our effective depth is 0.52. So if we solve for the QU net, another formula for the uh, one-way shear QU net is equals to PU over area squared. No? So dapat equal na siya sa capacity po, shear capacity or footing. No? So again, ang critical section for shearing is from the face of the column, the distance effective depth to that section. So mo ng uh, distance D. So to solve for the Q net, so that is equals to 1818 over 2.4 quantity squared, so 315. Therefore, our ultimate shear capacity for wide beam action is just simply 315, no? So Q unit times the area for the critical section. So that is 0.5, di ba? 0.505. No? So yun sa nato ni pagko ang 0.505. If this is 2.4 and this is from the center of, okay, from the center of uh, the footing or the column, no? So kani 2.4 katunga sa 2.4 is 1.2, no? 1.2 katunga sa column, pilang po ning column. So this is 1.2 minus half of 0.35 minus D. So that is exactly 0.505. For the bending, so for the area, no, for the shear, this critical section, ano pasabot sa katong area, critical area. So point, kini nga area, 0.505 times 2.4. So muni ang ato ang factored shear force, no, or wide beam shear action. So 382.54. So nagets ninyo ning BW, no, times D for the area. So this one, this should be the inyo ning i-determine kung pila ni siya ka distance diri. And then, so again, yun sa pagkuha ang 0.505 is just simply 2.4 divided by 2 minus 0.35 divided by 2 minus 0.52, which is the effective depth, that is 0.505. Okay? So therefore, naanatay factor shear force, but ang pangutana is shear stress. So since naanatay shear force, then or there's shear stress, that is just simply the shear force, nominal shear force divided by BW times D. Nominal shear stress, so it's just VU divided by the phi, no? Divided by BW times D. So VU for one-way shear or wide beam shear, 382.54. Again, multiplied by 1,000 kay in mm tanan para ang unit is in MPa. So, divided by 0.75, no, ang atong VU kay tungod for the nominal, no, nominal kining shear stress, nominal shear stress siya. Okay? And reduction factor for nominal is, for shear is 0.75. So, 2,400 and 520 mo ni siya ang effective depth. or one way. So doon na kay, so nanatay answer nga 0.405 MPa. And then letter B, shear stress naman for two-way. Kung two-way naman, nga consideration, so otro na po ang ato ang effective depth, no? So instead of D over 2, we immediately multiply it by D minus D, deduct it by D. So therefore, your Q unit is now 1818 over 2.4 squared, or you can use the other also formula, no, for determining the VU. So you have there VU for punching, no, is equals to PU minus Q unit times the inner area. So nanamtay PU nga 1818 minus 315.1625. Inner is katong VO na to, no, nga 0.86 by 0.91. No? So how did we get this 0.91? Of course, muna siya ang d over 2. Kini nga diha, 0.51. 0.51 divided by 2. Muna siya diha paingon. No, diha paingon. So, therefore, you'll have here uh, 0.91 meters, and in this direction 0.80. Okay, 3.35 man na siya, no? And then here, kani kay zero point 0.4 plus 0.51 divided by 2. So, nalang 0.910. So, therefore, you'll have your nominal ultimate factored shear force, the factored shear force, a total of 1599. So, for the shear stress for two-way action, so more gapon yung formula, no? BU times divided by the phi times BO. So ang BO, duha ka 860, duha ka 910, multiplied by the effective depth, which is 510. Again, multiply nimo ang 159.70.99 times 1,000 divided by 0.75. So you'll have the punching shear or shear stress, no, for two-way action is 1.16. No? So we solved already. And the last is pila ka 20 mm nga reinforcement ang gamiton. No? So for the effective depth, we use D as equals to 152 for bending, no? One-way shear. So we consider one-way shear. So that is the critical section, and so you have there this portion here, no, is 2.4 kini nga distance, no? 2.4 minus divided by 2 minus 0.35 divided by 2 is 1.025. So for bending, from the face of the support, no, critical section na siya gikan diha towards the end of our footing, no. Diha ang critical section for bending. So kanang naka-color of pink, total area. This is for the uh, cross-sectional. This is the top plan, no. So many ang total area for critical section for bending. So if imo na siyang isolve, no, so natay MU, okay, for bending, no, at this from the face of the support due to this pressure 315.625, to come to uniform pressure induced by this 1818, no, towards our soil. So using the moment arm, no, nga 1.025, diba? Ang you can delete from the face of the wall. Okay. From the face we have there. So you have your MU as equals to 1.025 times 2.4 times 1.025 over 2. So you'll have now your ultimate moment for bending 397.92 kilonewton meter. Okay. So to solve for your Rn, then you can solve Mu, okay? And then you have your katunga formula, no? So mo ang rho, and then check for rho minimum. So ang rho minimum is 0.0185, and this is smaller than the rho. If you solve this is smaller than the rho min. Therefore, use the rho minimum, di ba? So which is 0.005, which is uh, 1.4 over 280. No? 0.005, ito naman is 0.002 lang. So, ang rumin, ang ang ganito. Ano siya mag-govern. So, therefore, choose the rumin 0.005. So, mupod na. No? Pag-check na to sa row na to, mga formula, auto dyan na siya ibangka sa atong row minimum, no? Sa atong duha ka formula. So instead of now, our row BD, area of steel is equals to row BD, then since our row minimum governs because the computed row value or steel ratio is smaller than the row minimum, which is 1.4 over Fy, katong pinakagamay, di ba? Sa duha ka formula sa row min. So we use 0.005. Then the area of the steel bars will then be determined na, no? So 520 ato ang effective depth for bending. Of course, the effective depth that will be used is for the wide beam. So katong one-way shear, no? So ang gamiton nga effective depth para sa bending, no? Critical section for bending. So again, none of the areas of steel bars. So pila man ka number of steel bars. So kung 20 mm atong steel bars, so you have there 6242 divided by the area of one steel bars, no? A sub the area of the one steel bars. So areas of steel bars, diba, kay pi over 4 b squared. No? So ang diameter is 20, therefore, pila ka number of bars? So 19.86 pieces, or that's simply 20 pieces. So pagkuha na po din sa spacing, no? So natin 9 at 20 ka main reinforcement. That ends the uh, sample number 2, no? For the sample number 2. Okay? Naamoy pangutana. So na natin example, no, sa shear critical section, bending critical section, computation sa atong footing. Okay? So there are some other samples here, and basically similar lang, no? Similar siya sa ato ang gihatag nga two examples. So you can refer to these examples also. Pwede mo mag basa further for this example. Okay, so that ends for our lecture 10. No? So you can continue reading on more examples of the PowerPoint. No? So timanan lang to ninyo. Ang reduction factor for shear is 0.25, for bending is 0.90, and the formulas involved And in the computations of the area of the steel bars, so you have to compute for the steel ratio or raw. No? Steel ratio, i-check nimo katong formula sa steel ratio nga kini, diba? This formula. Pero dapat i-check nimo siya kung mas asa may mas gamay sa ilaa sa raw minimum. So, dapat dili siya mo below sa raw minimum. No? So, kung mas dako siya sa raw minimum, then choose it. Pero gamay kay siya sa raw minimum, so dapat raw minimum ra gud imo ganito, no? Raw min. So pareha ani anti-formula duha sa raw minimum, no? Isa ra 1.4 over Fy or 0.25 times square root of sig prime over Fy. Depende pod kung Fy niya is gamay lang. So, dako-dako yun yung raw min, diba? Pero in the case kung Fy is 418, mas gamay na siya sa kini nga formula 1.4 over Fy. So, depende kung sa iyang romin, imo rin ang i-compare sa still ratio mo na compute. So, dapat ang pilion mo, dapat ang dili jud mo below ang romin. So, dapat greater than romin. But not greater than the raw max. No? Katong sa itong design sa uh, RC, reinforced concrete, which is 0.75 of row balance. Row balance in this mode. Okay, so I think we will just end for the footing, no, analysis. Footing, napay different footing, napay mga strap, no. You have to take note of all this different like combined footing. And sa pressure lang gid siya, no? Ang pressure kanilang mag-shear and moment diagram mo, no? Kung na loading, may pressure. So take note of all these different scenarios, no? Different types of footing. Okay. So again, for the number of pieces of the steel bars, diba? Area, total area of the steel divided by the one area of steel bar. So, ang number of pieces. Pag-determine sa number of pieces sa steel bars. Okay? And you have also footing on piles, no? Napoy sa piles. There are different types of footing on piles, no? Or pile caps. So, kasagaran, kung problematic ay ang soil, no? We use footing on piles, no? Or pile caps. So, in the picture, you can see these are piles, no? And combining more than one pile, no? The pile cap, and then siya mag-carry of load. No? So, this is footing on piles, no, with pile cap. So that's simple. This is simple illustration. So usually, if the bearing capacity of the upper soil layer is insufficient for a spread foundation, so deep foundation dita. So naatay file pile ang ato ang foundation, no? So kay we need a deeper depth towards the strata of the soil, no, underneath. So piles are used to transfer the loads to this deeper strata. So kay shallow foundation naman tong mga spread footing, combined footing, sa katong sa kaanan gyud, no, dili kayo siya problematic ang soil bearing capacity. However, if the soil bearing capacity is really to be uh, is dapat deeper pa gyud ang makita na po ang medyo uh, taas-taas nga bearing capacity sa soil, no, deeper strata pa. So we use these piles. Piles are generally arranged in groups or cluster. So one under each column. So the group is capped. It requires group of piles. So it is capped by a spread footing or cap. No, usually spread footing. Consider siya pile cap yung tawag na to. And that distributes the column load to all piles in the groups. Kung group of 4, group of 6, no? Ang piles ni mo ma-support sa loading sa isa ka column. These pile caps are in most ways very similar to footings on soil except the reaction on caps act as a concentrated loads at the individual piles rather than a distributed pressure. So karon ang pag-analyze nato murag gyapon siya og spread footing, but ang diri na lang sa reaction kay individual siya nga reaction sa ah, per column, no, nga naay ah, diha sa ilalom, no, sa pile cap dito. So we in the construction, no, we design pile cap under eccentric or concentric load, no, based on the assumptions. So pile cap na to in natin siya po, no. So you have their minimum anchorage, no, of our pile cap, 150 mm from the top of the column or the piles. And then from that, there's a covering of 75 mm towards the main reinforcement. And then you have there 300 mm, yeah, a minimum of 300 mm from the main reinforcement, no? Center line of the uh, from the steel covering, steel covering. So ang steel covering just at the bottom of the main reinforcement bar, 75. Gikan di pa ingon dito sa face sa atong pile cap na top portion na tay minimum ana nga requirement niya 300 mm. So that's minimum. So the cap is, it should be perfectly rigid, no? And pile heads are hinged to the pile cap. So usually that is that these pile heads are hinged to the pile cap so that we can avoid, no, bending moment transmitted from the pile cap to the piles.
Sir John, nag-luto si Jonathan. Papagaling over kami. So, ikaw lang magtutok ako para akong ilan. One, let's go. Let's go.
Piles are considered as an elastic column, therefore the deformation and stress distribution are planar. And number four, pile caps like spread footings may have pedestals, no? Stepped or sloping tops. So pwede siya or siya og pedestal nga kung ano. So pwede ko siya na slope diri, no? Sloping. Pile cap should be large enough to have a minimum edge distance of 150 mm concrete beyond the outside surface of the exterior piles. So, may siya pasabot 150 mm. And the reinforcing bars are placed a clear distance of 75 mm. So, doon na tayo main reinforcements at pile cap na minimum na gina siya covering the, no, from the piles 75 mm to the face of the bottom of the main reinforcement. Then, depth of footing above the bottom reinforcement shall be less than 300 mm for footing on piles. So, minimum po daw 300 mm. Under concentric load, no, all piles in the same group are assumed to carry equal axial loads. So, kana all files distribute na siya kung lima sila kabuok. So kung pila niyang gitransmit diri diha paingon din i-divide by 5 na lang siya dayon. So the soil under the pile is not assumed to offer any support. So that is the simple assumptions no, in the designing footing on piles, in the design of footing on piles. So if we see no, muna ang schematic diagrams ato ang arrangements or reinforcement sa pile caps. No? So, tanaw ta o ibutang na to ang ato ang sa centroidal no, ang kining column na nag-carry of load na transmit kayo sa atong piles. So you have there the main reinforcement sa piles, no? This one. Then 150 mm from the top of the piles to the concrete no? Sa bottom portion of our pile cup. Then 0.75 dayon po na mm paing dito sa main reinforcement. So this is the interface of the cross section of a pile on cups, no? Floating on piles. So there are different types of floating on piles, no? May type 1, type 2, type 3, type 4, type 5, and type 6. So you can see here, type 4, the column starter bars or the column starter bars or doubles. You have type 1 steel reinforced bars placed at the bottom in the X direction at 90 degrees. So these are the conditions of the different types of arrangement of reinforcement. No? And, putting on So for the pile reaction formula, take note of this formula class. No? R, that is the pile reaction formula, is equals to P over N plus and minus is my times the moment and x times is divided by the summation of x squared plus and minus also the moment induced along the x-axis no kani. So in that direction times y times the summation of the squared also of the squared distances no, per pile. So muning x from the centroid no, sa itong location sa loading ng x direction muna itong y direction. So for example no naatay pile footing niya na ay PU nga load nga 4,500 kilonewton. Ang column 600 mm by 600 column transmit. No? So when I moment along the x, which is 420 kilonewton, and moment along the y, which is 380 kilonewton. So using effective depth of 1.2 and the shear reduction factor 0.55, determine the biggest pile reaction and determine the smallest pile reaction and determine the critical wide shear stress. So how to start saan man to pag-compute. No? So if you have 9 piles on plan, so pile number 1, so we have there to determine for your distances, no? PU. No? Ang kaning X na siya ay 1.5 no? from the center siya distance na 1.5. Okay? So summation, so pila man ni siya ka 1.5, 1, 2, 3, 4, 5, 6, 1.5 in the sa X and then sa Y Pod ni 1.8. 1, 2. So, pila ka book sila piles along this Y. So, if there 1, 2, 3, 4, 5, 6, 7, 8, okay? 1, 2, 3, 4, 5, 6. So, you'll have there summation of x squared and y squared. So, to solve for the R max, you have 4, 5 over 9. Di ba? Ang PU, 4, 5. And pila man ka piles, 9. So, plus 380 times 1.5, 380 m y, then summation of x squared 13.5 and my 420 times x, which is 1 point y, or the mx times y can be my times y, my times x, diba? Ayun, divided by 19.44, which is the summation of all the y's. So, kana siya kay my, so may moment arm ng x. Kana siya kay mx, moment arm is y. So therefore, you were able to determine the biggest part action. So our max will be 581.11 kilograms. So minimum, katurong minus na po inside. So 418.89. So for the critical wide beam shear stress, so naman kay RU, nakadetermine, diba? Alam di ko Pinilan ko nag-istorya na wala po mo na reklamo no, nga wala mo siya kuan. Okay, so ang smallest, asa man ang smallest? Pinakatumoy po, diri. Ay na to. So kung diha ta magbase ang moment arm na to, x mo gihapon no, from the sine 1.5. So pila na ka x? 1.5 squared times 6 and 1.5, 1.8 squared times 6. So you'll have your minimum is equals to 418.89. Dayon, for the critical for wide beam shear, so it is the which is 581.11. So therefore, if we solve the R1 section, which is the critical section for one-way shear, from the center towards here, a distance 1.2 meters. Now, effective depth is given in the problem. So, kung nakandihan daw pa to the critical section for shear is 1.2 meters. So, therefore, we can solve for the reactions for each of these pile, no? Kaning pile na we consider as critical for shear, one-way shear, no? Which is a distance d from the center. Wednesday sa gabi.
Wednesday sa gabi.
Ang katong kuan, kasiyahan. Oh, umabot sa gabi eh. 19, di ba? 19, sir.
Oh, kung bakit mo daw gabi?
Okay, so
Yan naman. Ay, ba't di ba nabasa Thursday, no? Nabasa Thursday. Wala. Ay, hindi ka pwede dyan po.
okay, so for
Ah, okay, okay, okay.
R2, so kung R2 po ta, no, so diri, file number 2. So, 4, 5 over 9. Kato gyapon sa formula, no? Wala na din time moment arm, no? For MY, kay naman ta diri sa centroid. So, lang siya. Divided by 13.5. Of course, the summation of all the uh, x, no? Along the x direction, summation of x squared. Then, for the mx, we have 420. So, katong y, may direction, 1.8, 1.8, diba ka na? 1.8. And then, divided by the summation of y squared. So, you get R2 o 538.89. Kung diripod ka, sa R3 na pod, katong yapang yung formula, no? PU over the number of the piles. So, 4, 5 divided by 9, diba? Divided sa total number of piles. Plus 380. So, kung the other side na siya, ang R diri, portion, no? Minus 1.5 na siya, no? 3 minus 1.5 minus, ano lang siya? Opposing, no? Opposing, so minus 1.5 divided by 13.5 and 420, ang moment arm is 1.8 gihapon, no? Divided by 19.44. So, kanina formula, no? Nakita natin yun in the previous slide. So, take note of all this. So, therefore, i-add nimo ang R1 to R1 plus R2 plus R3. Okay. Then, you determine for the total shear that is critical for one-way shearing. So, R1 plus R2 plus R3. So, if we add it, then we can see that this is, or you can sum up forces vertical equals to 0, which is equals to VU times for one wide beam shear plus, of course, 1667 kilonewton. So you'll have now your shear, factor shear force for the critical section. So again, for the shear stress, so you multiply the alternate shear strength, or actual shear over the 0.75 reduction factor for shear. Then EW, which is 4.7 times the effective depth, which is 1.2 meters or 1,200. So therefore, the shear stress, for one way shear only is 0.382. So that resolves the problem on piles. So there are still other pile examples here. No? So you can refer to some of the examples yourself. Okay, so ang PU, i-divide ka ng N, so pinaka number of piles. So similar examples also are given in the problem. Okay, so I think that would end the discussion for this morning, where we discuss about the pile capacity, no, shear, and determine the uh, design and analysis of our footing, no? Katong sa shallow foundation and sa deep, katong sa footing on piles. and take note of all these formulas that you need to memorize. Okay, or your uh, next activity, since it's already 9 o'clock, I will be posting on the our Google Classroom. But all you have to do is you write or you solve at least three problems for shallow and at least three problems for piles. But this time you refer to the examples and do not copy the examples. Rather, you put conditions. What if the value is this? No, one of the parameters. You have some conditions. You analyze the problem. Then you say, what if the piles are only five? Yan, pila po iyang capacity. No? You will then determine. So you alter, you put some analysis or you try to analyze. Ano na ka, what if kanilang ang value? What if kaya ba siya? Try to solve them. So, three problems lang for shallow, no? Such as katong may combined footing, may spread footing, no? Isolated footing, wall footing. Tulo lang adto na may mga sample problems. Magkuha lang mo dito. Dayon. Manual lang gihapon ang pag-compute. No? Tulo lang ka problems. Tulo po dahil sa piles. Dahil example sa piles. So, tulo lang gyapon katong examples inyong awatan ang tan-awon is what if lang, what if kini ang value unsa po dahil ang result, di ba? Na kay author isa lang ka parameter para dili ra kay ka ah, simple lang analysis. What if? So you have your condition, no? In your problem statement, you write the sample problem. So, itang ninyong problem. Pwede ka itong sample problem. Then, na din kay second statement, no? Para sa imo ang what if. So, sumpayan na nga din mo. If, okay? So, na problem statement, dyan ha, walay, i-submit nga, walay problem statement. So, na problem statement, ayun, nada what if. Meaning to say, unsa imo ang giilisan, no? Unsa may imo ang analyze ato. What if ang footing is only this or having this dimension, no? Safe pa ba siya kung kato yung capacity? Yan na. So, pag ang dimension mo, i-outer. Okay, did you get my instruction? Please give me a thumbs up. So, sa 12 noon ninyo i-submit. Okay, so that would be all for now. You can start now doing your sit work, as I post your activity for this morning. Thank you, everyone. And please open your camera for the documentation para maka-print screen ko. Okay. 1, 2, okay. 3, okay. Thank you. So, 7.
Jose, Jose.
And then, isa pa nga. Isa ma next page.
Sir, excuse me.
So, 26 ra ka mo.
Somewhere.
Check lang ko attendance list si absent ron. Ababon.
Good morning, ma'am. Present po.
Date is 18. So, baton. Awanon. Absent. Awanon. Absent. Bacolio. Present. Absent. Bacolio. Present. Bacolio. Bangot.
Present, ma'am.
Bazaar. Absent si Bazaar. Kanakit absent. Bogo.
Present, ma'am.
Braga. Bohos. Absent. Bohos. Absent. Kalugay.
Present, ma'am.
Kamaraw. Kamaraw absent. Kambo.
Present, ma'am. Good morning.
Cardanio.
Present, ma'am. Good morning.
Casimio. Casimio.
Present, ma'am. Good morning.
Dal. Dal. Absent. Murag drop na galing ni si Dal ay lagi present ni. Duterte. Absent po si Duterte. Imano. Absent. Falyarna. Absent. Fuentes Eugene. Eugene. Fuentes Eugene. Absent. Absent. Fuentes Giselle. Giselle. Fuentes Giselle. Absent. Gilly. Absent. Agisan.
Present po, ma'am. Good morning.
Ahalia. Ahalia. Absent. Absent. Labaon. Labaon. Lonzaga. Lonzaga. Absent. Mas taas
Good
mo.
morning, ma'am. Present po contest, ma'am.
Ganina, nanawag ko nimo hama kanidagan.
Kaya nawala ka dyan ako internet, ma'am.
Giselle.
Bawal niya, ma'am. Nagkuha lang ako sa kanya. Then, search ko sa
So ka, Bacolio?
ma'am. Nag-search ko sa ma'am. Kaya kung ano ko lang. Balik ako dito.
Dali, dali lang ka. Basag nyawa na.
Ito lang. Open ko.
Ya, si Luyaw na
Present po, ma'am.
si Makas,
Present nakas, ma'am.
Multi Falcon, absent, Multi Falcon, Morato, Morato, absent, Nalogon, Nalogon, absent, ha? Tubag na yun, sabi, may katubag. Nisperos,
Good morning, ma'am. Present po.
Present,
Ito, ma'am.
Miss